Hello, good evening, everyone. Thank you for the introduction. Hironobu, can everybody hear me?
Yes, I can hear you.
Wonderful. Let's get started.
Yes, please
Today's
start.
webinar is all about the systems and strategies of research grants abroad. So basically, I will give you a lecture on international research grants with a specific focus from the United States. They have a lot of international research grants that are available either as a cooperating scientist or as a cooperating institute. And two of the research funding organizations we'll talk about today is NIH, the National Institutes of Health, and then the National Science Foundation. And some of these will be familiar with you if you apply for JSPS grants. I think there's a lot of things in common with the American funding bodies. So just to introduce Cactus, Editage. Editage is an organization to help researchers and help bridge the gap between researchers and peer-reviewed journals and accelerate the process of publishing high-quality research. We've helped over 500,000 researchers publish over 2 million papers, and we've been around in business for over 20 years. And we also give a lot of webinars, such as today's webinar. And I really hope you find today's webinar useful. Feel free to ask any questions you want in the Q&A box, and I will get to your questions during the Q&A period. I am currently based in Moscow in Russia at the Russian Academy of Sciences. I am also an adjunct professor in the Department of Entomology at Rutgers University. I have many years of experience of obtaining American grants. In fact, I've had American grants for 25 years, and a lot of them are international grants. So, and I have to go through the same process of obtaining the grants as I will show you in this webinar. So I'm also an editor for a scientific journal, a Wiley journal called Integrative Zoology. We're ranked in the top 5% of all zoological journals. In fact, we had our last International Congress of Zoology was held in conjunction with the Japanese Zoological Society as one of our partners. So we do cooperate a lot with Japan. So I've spent most of my career in China, first at the Institute of Chemistry, Chinese Academy of Sciences, and then the Institute of Zoology, Chinese Academy of Sciences. And then I have joint positions with the US and Russia. So I still work a lot in Asia, and I'm applying mostly for international grants. So I have a lot of experience, and I'll walk you through this process. And I've even served as a reviewer on some National Science Foundation proposals, so I can tell you what goes on the reviewing stage. And the most important thing, just to know what grants are. Grants are basically non-repayable funds given out by grant makers, funding agencies, often government agencies. They can also be corporations or research foundations, and these funds go to a recipient. It's usually an organization or a nonprofit entity, or it can be an educational institute or like your research institute. And it can even go to a business or even an individual. So, I mean, you can register either as a university, you can also register as maybe a sole proprietorship, like a business, individual business. Yeah, so there's a big diversity of who can receive grants, but it's usually a nonprofit entity. And to receive your grant, grant writing is required. This is a very laborious process. And if I visit a grant office, usually every university has a grants office, and the staff in the grants office will tell you you need to spend at least 1/4 of your time writing grants. So be prepared to spend a lot of time writing these, either as a grant proposals or grant applications. So this has to be a part of your every day and every week, is thinking about grants and also preliminary experiments, because you need to show, like a pilot study is very important to have some pilot studies, especially when you're trying to get into a new project. They want to see some preliminary data. So basically, a grant proposal is an application for acquiring financial aid for your research work. Again, non-repayable, so make sure if you get awarded $100,000 or $1 million, you also need to spend that money, because if you don't spend it, then you have to give it back at the end of your project. And sometimes you can apply for a no-cost extension. Like if the project is not finished, you can ask for more time to extend the grant, just for the timeline. But usually, you cannot ask for more money, but you can get more time to actually just finish the project. So how to write a grant proposal. So the outline of the webinar, the why should you write grants. I'll walk you through the application process. And then go over the criteria for evaluating grants. Usually there's a grant peer review, and then there's like a grant panel, where a panel will get together and then make a decision on funding or not. Then I'll go over the 10 core sections of your grant proposal, what every grant proposal should need, and finally give you some tips on effective writing of your grants. So why should you write grants? Basically, in science, the credit goes to the man or woman who convinces the world, not to the man or woman whom the first idea occurs. So it's very important to be able to communicate your ideas. You may come up with your research idea, but you need to put it down in writing and apply for it. And that is very competitive. So there's different types of grants. There's research grants. There's programs for developing program development grants. There's career development grants and fellowships. These are open to early career researchers. And there's research training grants. You can also apply for travel grants, and there's conference grants as well. And as an early career researcher, I would go for these smaller grants first. And the grants and fellowships, you can get like a graduate student, a graduate fellowship grant, or a postdoc fellowship grant. These are good grants to get you started. And then later on in your career, when you become a principal investigator or a PI, then you can go for these big research grants. So I started small. I got a graduate fellowship with NSF and then a postdoctoral fellowship with NSF. And then I started writing the big grants, because you're in competition with all the top professors. So why apply for research grants? Well, first of all, you want to get funding for your research. It enables you to conduct large-scale research projects. Again, like I mentioned earlier, if you get these smaller grants to start you out, this will pave the way and open doors for future grants and help your career and competitive abilities. And getting a grant really opens so many doors with being able to collaborate between researchers and labs, and enables mentoring of young researchers by building a team or a lab. The research grants I'm applying for now require that 60% of the personnel are under the age of 35, because they want the money to develop and build young scientists. And that's an example from Russia. And in some cases, your results can have surprising secondary results that can direct future research projects. And also this last line, this is especially true for me when I was in China. I had a National Science Foundation grant for a postdoc fellowship for 2 years. It was really hard to get permission to do research in China, but then I applied for the Chinese National Science Foundation grant. And so I had grants from both China and US. And then when I had grants from both countries, I instantly got approval and permission to do my research projects. So it's also important in your host country, especially if you're doing an international collaboration, to get grants from multiple funding sources. So here's some funding agencies. I mentioned NIH, National Institutes of Health, and also National Science Foundation. There's a few grants that are available for international researchers. One is a doctoral dissertation research improvement grants. We used to call these DIGs, now they're called DRIGs. Basically, you have to be affiliated with an American university, and this is one of the few grants that's available for foreigners. There's also something called the PIRE, P-I-R-E, Partnerships for International Research, and I'll go over that later. And here, I think your university, your entire institute can be a cooperating partner. And then the USDA also has a lot of grants from the Forest Service, also the Plant Quarantine Lab, or the agency, Animal Plant Health Inspection Agency. They do a lot of international cooperations, and it's possible to register on the government websites. There's something called SAM, so Systems for Award Management, and I'll go over how to register there. You can register your university, your research institute, or even register as like an individual business. So NIH has the most money available out of all the government agencies. And compared to NSF, I think NSF is only like $5 or $6 billion. So yeah, this is by far the biggest source of funding. I encourage you to go to their website, find out how to register. There's a couple places, there's at least 3 places you have to register. There's grants.gov, there's this ERA Commons, and then your SAM account, Systems for Award Management. So there's at least 3 places you have to register. It takes a lot of time at first. So I would plan at least 2 or 3 months to get all these registrations completed. So stay up to date. You can browse the NIH website for grant opportunities and finding the appropriate grant funding. Check out the program solicitations. They also call these RFPs, so these requests for research proposals. Basically, it's a call for proposals. You can also check, so the open calls for applications, they call those FOAs. And then you can also check out the website, grants and funding. You can click on that section, or the NIH guide for grants and contracts. You can also check out what projects have been previously funded. And so here's the homepage for NIH. You can find the current calls, these FOAs, these calls for proposals. You can also look at what has been funded in the past, and the programs are very competitive, but the program officers, they will encourage you to apply. So you may want to consider a letter of intent, which I'll get into later. Basically you're notifying the program officers your intentions to apply for certain grants, and it's great to have this open door of communication. I've always been in contact with the program officers. Some of the funding rates can be very, very low. It could be like 5% or less. So they're very competitive, and good communication is key. And you can find out how to apply by clicking on these links. So here's a sample screenshot from finding grant funding. You can look at all these different categories. With all organizations, so there's FDA, NASA, NIH, NSF, and here you can search within NIH and figure out these are different program opportunities. There's over 16,000 of them. So it's good to narrow your search with keywords and look at the particular programs, and hopefully you can identify a good program. You can also see what has been funded in the past. Because it's public funds, every single award, the abstracts are available online, so you can see what has been funded in the past. Another important thing to do, I mentioned there's at least 3 stages of registering. You should also understand the systems and roles. So that's another important thing. Usually each university, there's at least 2 different roles. You may have the principal investigator and also the signatory official. So at least 2 people from your organization have to be registered, having roles. Usually it's your grants office that's doing this. So find out if your university already has registered or not. If not, then I would recommend you go through the process of registration. So I'm going to just show you, what happens when you click on the register button. But before that, these are the system and roles. So the 2 main systems, one is grants.gov. This is an online portal for all federal grant-making agencies. So NIH and also NSF, they both use grants.gov. And you can log in and make sure to set up an account in grants.gov. And then ERA Commons, this is specific for NIH. And after you submit your grant proposal, if you get awarded, this is basically your online platform for communication, for sharing and managing grant-related information. They also have a lot of pre-award tasks like tracking your application status, and basically all the communication with the grant officers, and also submitting your reports, like for example financial reports and progress reports. These can all be done within ERA Commons. So these are platforms to familiarize yourself with. And in order to apply for grants, this system for award management, basically this has to be your first step. And I'll get into that later, how to do that. The USDA grants, NSF, NIH, they all require your organization to have an identification number, like an entity identification. So these are the 2 roles. In the grants.gov, you have a point of contact, and then you have an authorized organizational representative. So these are 2 different people that you should have registered in grants.gov. And then ERA Commons, basically you just need to have the scientist and also a signatory official, usually a grants officer. And so when you submit your report, you submit it, and then there's a signature official that will approve your submission, and then it gets submitted to the organization. So that this works great. There's also something called Easy Federal Grants that basically has the same structure. You have an investigator and then a signatory official. So a minimum you need 2 people. So with your registration, start early. It can take 6 weeks or more to complete your registration. So there's, again, I mentioned that there's 3 registrations: the ERA Commons, System for Award Management, your SAM, and the grants.gov. So you should have an authorized representative, and these are also referred to as signatory officials or research grant administrators or a point of contact for ensuring that your organization is registered properly in the federal systems to apply for grant funding. So who needs an account? Well, as a principal investigator, you should have an ERA Commons account. And then your organization should have the SAM account. So, and also you can have individual registrations as well. But typically awards are given to organizations, not individuals. So when you're developing your research idea, make sure your research is in line with the overall mission of NIH or NSF. and develop specific research goals. You want to write out your aims and goals and emphasize all these aims and goals in all the sections of your grant proposal. And it's important that your idea is original. NIH, NSF, they're looking for novelty. They're looking for originality. They tend to fund high risk, high reward projects that will expand the frontiers of science. If your research is applied, maybe you should apply for a USDA grant. They have more applied research grants. But for basic research, you should emphasize that you're expanding the frontiers of science and human health if you're applying for NIH. At the same time, you should research other studies in your field and figure out what is the knowledge gap that you're trying to fill and how your research will enable this discovery. So you need to prove your novelty and the necessity of your research and make a convincing argument. And you should fit your studies in with the existing literature. So you should have also a good literature review in the introduction of your grant. I had mentioned before letters of intent. Basically, this is optional usually, but find out if your specific program that you're applying to requires this or not. So contact the program officers and also read the program solicitation, the request for proposals. See if this is required or not. Usually they're not required or binding, but often, and I can advise you very strongly to submit one if you notice a funding opportunity, this NOFO, or notice of special interest, request one. So basically, you're letting the program officers know that you're intending to apply for the grant. And the reviewers of your grant will not see this, only the program officers. So it's kind of like, when you submit a manuscript to a journal, you're writing a cover letter to the editor-in-chief, convincing the editor-in-chief that your research is novel. Maybe the reviewers will not see this cover letter, but the decision makers will see it. So this letter of intent will not affect how reviewers score your application because they won't see this letter. Only the program officers will see it. This also helps the staff, the program officers, to identify potential issues you need to address before you apply. And you can include these additional pieces of information when they suggest this. So you can go on the NIH website, and they have a lot of advice on how to write a letter of intent. And basically, you should have a descriptive title of your proposed research, all the contact information, and have a concise description, like an abstract of your proposed project. And then the program officers will use this information to determine whether your research is a good fit or not for the government organization giving the funding. So this can save you a lot of time. Like if they do not encourage you to apply, then don't waste 3 or 6 months of your time applying for it. Maybe find a different funding opportunity. So it's good to have communication. And then you can describe how your research plans relate with the research with special considerations, such as human subjects, clinical trials, or animal research. And this can help the NIH staff identify if there's any problems and see if it's a good match for their program. And you can also specify if you're working with pathogens, what pathogens you're planning to study. And the staff can help, can compare that with opportunity-specific requirements about that type of pathogen. So it's good to get, it's like a consultation. Consider this a consultation. And this is welcomed by the program officers. Okay, moving on from letters of intent. Your project plan should contain the following elements. An overview of your project. This is basically like a research statement. So you can clearly state your goals and purpose of your research, basically the justification of your research, and then your overall research strategy, including your background information, importance of your research, the novelty of your research, the design methodology, expected results, maybe some preliminary data, your pilot studies, and also you should be honest about the risks and potential shortcomings of your study. And then your backup plans, your countermeasures, your plan B, your plan C, your plan D, E, and F. Make sure you have backup plans as well, in case your research doesn't work out. Also, your budget. This is a very important part of your project. Often it takes far longer than you originally think it'll take. So leave a lot of time to put together your budget. So then you want to submit your grant application. NIH usually has deadlines. Sometimes, like for example, NSF, they have open deadlines, which means there are no deadlines. So yeah, you basically can submit your application whenever you want. So check to see if there's a deadline or not. And keep in mind, deadlines are strictly adhered to. Even if you're 1 minute late, they will not accept your proposal. And then the review process, this also works for NSF. Your proposal will be peer reviewed by experts in your field. They do a really good job at identifying the top experts. I've always been very impressed about the quality of the reviews I get. So you first get peer reviewed, usually 2 or 3 scientists, evaluate the scientific quality, originality, and feasibility, and these are all rated on your proposal. Usually it's excellent, very good, good, fair, and poor. And then these reviews come and there's an advisory council or a panel review, and basically a group gets together at the headquarters of NSF or NIH where your proposals are evaluated alongside all the other proposals. Then they rank them and decide whether to allocate funding or not. Usually there's a green pile, which is definitely fund. There's a yellow pile where fund if funding is available, and then there's a red pile, which is reject. Often, most proposals go in the yellow category because the funding is very limited. Often, some of the funding rates are only like 5% or less, or 10% or less. So there are a lot more fundable proposals than there is money, unfortunately. So you may have an excellent proposal, but it might not get funded because of the limitations on the number of awards. So then there's a decision, notification of funding allocation. So based on your proposal and the quality, decision is made, and you'll receive a notice of award if successful. So then after you get the grant, usually they want you to start it within 6 months of your proposed starting date. I got my postdoctoral grant when I was actually still a doctoral student. So I had to very quickly finish my PhD, and I had to quit my postdoc at Michigan State University and start my postdoctoral fellowship before I only had like five or 6 months to start my project, or I lose the funding. So be prepared to start it on time, generally within 6 months of your proposed start date. And be prepared to report if it's a multi-year grant. You need to submit a report once a year, and then a final report at the end of your project. And if you do no cost extension, you can do another report. You can delay the final report submission till when the project is finished, even after your no cost extension. Very important to report on the broader impacts of your research. So if you're in the news, if you write popular science, if you're on the radio or on television, or if you go into conference presentations, these are very important for funding agencies. They report on everything you do. So if you have a podcast, or if you're on TV or on the radio, in addition to your publications, they want to know about it. And don't forget to include your grant funding on your publications. So you can acknowledge the funding, and then list the publications on your reports. And often, it's a nice database. You'll see your award, your abstract, and then your list of publications will be on the public view. So again, don't forget to write those grant numbers. So moving on to NSF, there's doctoral dissertation improvement grants. These are one of the few funding opportunities available for foreign scientists, but you have to be at a U.S. institute. And then there's basically You need to be at an accredited PhD granting university, having a campus located in the U.S., acting on behalf of their faculty members. So you can serve as a principal investigator, even as a student. But the doctoral student must be listed as the co-PI. So you go through your advisor, and there's no restrictions or limits. And then be prepared to have extra things like a biographical sketch. This is a 2-page curriculum vitae. So here I would list no more than 5 research papers that you've published, and you can basically try to cram your entire CV onto 2 pages, and include the most relevant publications for the grant you're proposing for. And then you have a budget. Usually there's no salaries for these dissertation improvement grants. But these are all very competitive research grants to support your research. Okay, now getting into like a research institute. So if you're applying as a research institute, you can go and check out NSF's International Funding Opportunities for Overseas Scientists. And they have an International Science and Engineering department. So it's the Office of International Science and Engineering, and you can check out their programs. I got all of my research grants through this as a American scientist at a foreign organization, mostly from China. But I also have, I know a lot of people in Japan that also got grants through the Office of International Science and Engineering. I had mentioned the Partnerships for International Research Experience and Education. So this is the main program. And also, if you want to host American researchers in your laboratories, they can apply through the International Research Experiences for Students, so the one above. But as an organization, a foreign organization, this is the program that you want to apply for. These can also be multi-million-dollar grants, and they tend to be quite big. But you'll need to have all your grants.gov registration. The NSF has their own registration. It's not ERA Commons. It's a different registration, and I'll walk you through that. And then your SAM, your Systems for Award Management. So here's the PIRE. You can view the guidelines, look at the program solicitation for these grant opportunities. They're very competitive. They're multi-year grants, and it's a wonderful funding source for international cooperation. So some practical tips: review the past awards, take advice of the program updates, and as NIH, they like letters of intent. Well, NSF, it's a good idea to contact the program officers before you submit. Oh, here we go. Yeah, you need that letter of intent. They want to hear from you, so you must do that. And then there's a limitation of 1 proposal per institution. So if there's more than 1 professor at your research university or institute, you may have an internal competition to see which PI can apply. And then don't forget you need to focus on basic research that focuses on significant societal challenges related to climate change, clean energy, that canalizes international teams. So look at that. This is a strategic objective of NSF. So you want to make sure you have a big societal impact on whatever your research is. You can apply for really large grants. You can also apply for a smaller grant with a shorter duration that might increase your chances of getting funded. So take all these things into consideration. And here again, they want you to address societal challenges on international scales. And it seems like climate change and clean energy are 2 strategic objectives of this grant. So again, read this. It's a very long document on the proposal and award policies. They also, like NIH, they want you to submit your grants through grants.gov, but you can also submit it through these other websites as well. But I think if you register on grants.gov, you should be okay for both NIH and NSF. And is your organization new to applying for NSF funding? If the answer is yes, then you need to have a SAM registration. This is a system for award management. And then your university or your organization will be assigned a unique identification number. This used to be a DUNS number, but now they've changed it. They eliminated the DUNS number and they have this. And they recommend that you do this at least 3 months or 90 days before you plan to submit your grant. So that's important. And here's a timeline for applying for NSF grants through research.gov or grants.gov. So obtain your SAM registration, do this 3 months in advance, and then you can register with NSF or NIH, and then you can put together your proposal and submit that, and you should be set and competitive for an award. So that's just a rough timeline of your proposal, or from registration in SAM, and then registering in NSF or NIH, and then submitting your proposal in time before the deadline. So this is your system for award management. The most important thing here, and for those of you in the grants offices at universities, or whatever research institute or small business, you need to have, you'll have one account, and one person will be in charge of that account. And it's very important to get your unique identity number. The most important thing here is that this should be free. And after you register, you might get a lot of junk mail saying that, oh, your registration is lapsing. And you may get a lot of confusing emails from third-party organizations. You should ignore them. In fact, I wanted to share with you, I will go on to the next slide. So you register on SAM. You set up a SAM account. You're going to need an email address and a phone number. So again, there's no more DUNS number, and each university and research institute gets assigned a unique identity number. So you set up your account, and then your registration will be valid for 1 year. So you have to renew this every year. So you make sure you have an email address and telephone number, because they have two-factor authentication. So make sure you have those, and then the timeline for your registration, it should take just a few weeks. There's also, if you're listed as a cooperator, if you're not receiving money directly, you can choose just to get an entity ID. That means you can't apply directly for federal grants, but you can be listed as a cooperator and submit reports. So you want to see if you want a full registration or just have a unique identity ID. But you'll want a full registration if you want to directly apply for the awards. And then finally, after you get you submit on SAM, then you have to wait, and the account registration will just take a day. And then there's something called a cage code assignment. This can take up to 10 business days. Basically, they're just going to check to see. There's a defense logistics company that it seems very complicated, but there's a video available here, so you can click on the link and watch the video. And just to save time, I don't want to spend too much time on this. And then for Japan, to get your unique identity number, there's country-specific information. I went online and I checked out what you need in Japan. So when you are registering on SAM, you're going to need either a corporate number, this is your VIT number, tax number, and there's an example, or your Teikoku number, and you'll have this number. So those are extra pieces of information that you need if you're registering from Japan. And I just wanted to show One cautionary tale, you will get bombarded with emails about, from third parties wanting to help you with your SAM registration. Just ignore the junk emails. SAM is completely for free, and you do not need to go through a third party. So just renew your SAM every year, and again, it's free of charge. Check, if you're worried about your registration, log into SAM and see if it's up to date, and usually it's fine. So you can be prepared to ignore a lot of junk mail. So now I'll go over the grant application process. So there's a preparation of your grant proposal, and then the writing of your grant proposal, and the review and result. That's the peer review stage, and then finally the delivery. So the preparation stage is very important. Here you want to identify sources of grant funding, go on the NIH and NSF and USDA web pages, identify your sources of funding. You should already have your research question and develop your idea and have your team, collaborators, and also, like for example, the PIRE grant, there's only one proposal submitted per institute, so you may have some internal procedures at your university before you apply for these big grants. Then the execution this is when you're actually writing your grant. So don't forget your letter of intent. So in addition to sending emails to the program officers, submit your letter of intent to the program officers. Read the guidance carefully. The first NSF grant that I applied for, I thought I had 3 pages was the maximum length of my proposal, but right before I was about to submit my grant, I found out they updated the guidance, and I had 5 pages to write my research idea. So it's always helpful, read the latest program solicitation. Then you develop your proposal and budget, and then submit your proposal before the deadline. And then the review and result. This can take up to 6 months. So your proposal gets reviewed. Some agencies will invite you to prepare a rebuttal to the reviewer comments. That's common in Russia and China, but maybe not in the U.S. But be prepared to, like authors responding to reviewer comments on a research paper. So you may have to prepare a rebuttal. And then you get notification of the award. You can accept or decline the award. And then delivery is you execute the project and then submit your progress reports on time, hopefully, and then publish your results. So in the preparation stage, you want to have a clear, testable idea, hypothesis with a broad significance, societal impacts, and implications. So you want to develop your idea through discussions with your colleagues. You want to have a very clear method and what resources and what challenges you have. So check out the call for proposals, figure out what they're funding, review all the funding bodies for suitability of your project, also statistics, what are the funding rates of your project, and you can research past awards. So make sure you have at least 3 to 6 months of preparation time. And also in this time, you can register on SAM, register on NIH and NSF. And then you want to prepare a draft proposal to clarify your thinking and problem solve early. And then identify what your research organization's internal review procedures are. Often these competitive grants only allow 1 submission per institute, so you may be competing with other laboratories and PIs at your research institute. So look on the websites of government organizations, Ministry of Education websites. You can also look at NGO sources such as Fulbright, Max Planck. Check out corporations. You can also ask your advisors, what funding opportunities have you applied for, and you can get advice from your senior colleagues. You can also go through the CVs of other researchers in the same field and see what research fellowships and research support that they received, and you can try to apply for the same funds. And you can, don't forget to visit your research grants office at your institution. They usually have a very thorough list of potential funding sources. And then the editage, we also have a link here. You can follow that for advice on obtaining funding. This is the writing stage. Don't forget to send that email to the program officers and also to your grant team, at your research office at your institute, and make sure check the suitability of your research to the grant. Then make a timeline for yourself to meet your grant deadline without rush. That's very important. Don't forget to read all the documents that are online. And you may have supplemental materials like letters of recommendation or research collaboration letters. Make sure you have all these. They can strengthen your proposal. Also get feedback on your writing. Share your research proposal with colleagues. Get input on your research proposal. Make sure you follow the research ethics and integrity. Make sure these are conveyed in your writing and project plan. And make sure you have everything spell checked, grammar checked. You can also employ professional editing services like Editage is happy to provide this service on research grants. Execution stage. So here, this is a UK organization. This just shows different fellowships and grants. Fellowships, these are great for early career researchers. For example, graduate fellowships, postdoc fellowships. So there's some guidance on that. So make sure you follow the guidance. Be prepared to have all of these sections of your proposal, and also make sure you have who's responsible for the at your organization, where the grant will be hosted. Have a good title. Make sure you have a clear start date and the duration of the grant. Usually they go from 1 year to 5 years on your grants. And sometimes, well, they want you to start the grant within 6 months of receiving the notification. So again, here it says the anticipated start date should be realistic and normally between 1 month and 6 months after the decision is made. And then, once the grant's been issued, start it on time. And then the applicants, you should clearly list all the principal investigators, the PIs and the co-PIs involved on the project. So be prepared to have summaries. These are usually published on the agency's websites. So you consider having a technical abstract and also a lay abstract. So you should have a plain English abstract that avoids the use of jargon, acronyms. It's good to have a lay summary that's understandable by the general public. You want to identify who's the beneficiary of your research. How will your research benefit other researchers in the field? What is the greater societal impact? You want to clearly communicate all this in your plan. Also have data management plans, communication plans as well. These are all part of the broader impacts of your research that these funding organizations are looking for. When I got funding from NSF, I made sure my broader impacts were clearly communicated, and I was on television, I was on the radio, these things, or I gave presentations even at high schools or elementary schools. They want to see, your outreach, your research outreach. It's very important, especially in the United States. And then clearly communicate what other support you have, what other grants you're applying for. Often you don't get enough money for one grant. You have to have 2 or 3 grants in order to have a project succeed. So be sure to list your other support as well, and then list your technical considerations. Again, you've seen this slide before. This is the review stage. It's usually a 2-stage review. So you have an expert peer review and then the committee review who makes the decisions on the proposals. When you have the committee review, sometimes this is communicated with the applicants, but not all the time. Sometimes the committee review will just make a decision without communicating with you, but you will receive all the comments from the peer reviewers and the panel review. And if you get rejected 1 year, you want to reapply and include responses, or at least take into account the comments from previous peer reviews of your grant, and that'll increase your chances of funding. Often you will not get funded the first year, but you may be funded the following year when you apply for a grant. So again, funding decisions are based on the scores by the reviewers and the committee members. Sometimes it's so competitive. Let's say there's 3 reviewers. You have excellent as the first review, excellent as the second review, and then very good as the third review, and then you get rejected for funding because the other grants had 3 ranks of excellent. It can be that competitive, or the panel review may rank your proposal higher because it fits with the strategic objectives of the funding organization. So again, it's a lot of factors go into the funding decision. And if your grant's awarded, you want to, they'll communicate, you want to reply to them your acceptance or rejection of the funds. And the grant application result, like this takes into an account the writing as well. So from writing until finding out the result can take 9 to 12 months. So be prepared to take a lot of time. So the evaluation of grants is important. You want to write clearly, and I think clear writing comes from clear thinking. So one can't exist without the other. So you want to think out your project clearly, and then that translates to clear writing in your grant proposal. So just having gone through the process of writing your grants, you can clearly communicate your research ideas and make them look attractive and competitive on paper. So these are some criteria that you want to basically communicate in your proposal, and this is the reviewers, they'll be looking at these 5 things in your proposal. They'll look at significance. Does your project address a critical problem? Is it innovative? They're looking at novelty. Does it develop different concepts or methods? They look at your team. Are you suitable to complete the project? Is your approach appropriate to accomplish the aims of the project? And is the environment, like your research institute, do you have the facilities are your facilities competitive to ensure the success of the project? And here's a citation. You can check that out on your own. And then the funders criteria, they look at a different set of criteria. So they take into account the reviewers' comments, and then the funders will look at the evaluations. They look at the match with the overall strategic objectives. For example, the PIRE grants want climate change and societal impacts and clean energy. So you probably have a higher chance of getting funded if you address those strategic objectives of your funder. So again, funders are more inclined to fund projects that are comprehensive, realistic, and transparent, and you follow all the guidelines. Very important to read and reread the guidelines for the proposal. You also want to have a justification of the cost of all your items. So this is just an overview of your grant proposal. You want to have your resources, your project plan, and your expected outcomes. And you want to communicate the originality of your research and then the relevance of your research. So again, all of this should be communicated in your grants. And there's a link down at the bottom of your screen. You can spend more time on this on your own time. So I'll quickly go over the 10 core sections of every research proposal, every grant proposal. This should be review for those that have experience in it, but I just wanted to stress some important parts of every grant proposal, what every grant proposal should contain. You should be clearly communicating your ideas. You should not place obstacles between your ideas and the readers. So again, having gone through the process of writing the grant proposal, that should clarify your thinking, and you should have a nice, clearly communicated research idea that's not overly ambitious. And then these are the core sections. A lot of these have a lot in common with the scientific paper. You want to have a title, abstract. Make sure you have a lay abstract that's understandable by the general public. Introduction, research, design, and methods. This is probably the most important part of your proposal, together with the preliminary studies or your pilot studies. Don't forget to address the limitations. If you don't do that, the reviewers will tell you what limitations you have. So be realistic on what your limitations are and have a plan B, a plan C, D, and F. Don't forget your budget. It'll take longer than you expect, and then who's on the project, and then the resources available at your institute, and then there's extra materials like letters of recommendation or letters of collaboration from your collaborators. So the title should be catchy. It should be contain all the information. It should be a mini summary of your entire study. This can be written at the very end. Make sure you have keywords that match the grant priorities in the title. So keep it short. Include the expected outcomes if you can. Use active verbs in your title to make it sound more compelling, and avoid the acronyms, and avoid general words that reduce the impact of your title. So you want to use the keywords to attract attention. Again, the abstract should be a standalone summary, and essentially it communicates the essence of your overall proposal. Don't forget to emphasize your aims and methods. Don't forget preliminary data. I cannot stress this enough. It's good to have pilot studies. And then you can have a technical abstract, but be prepared to have a lay abstract as well. Some of the panel reviewers, they may not be experts in your field, but they should be able to understand what you've proposed to do. And then a typical abstract should contain a sentence or two for each of these, rationale, your aims and hypotheses, your methods, and then your expected outcomes. Again, use keywords. You want to be able to use these to communicate that it's a good match to the remit of the funding body. So introduction, you'll introduce your research idea and fit it in the context of what is already known, and identify that research gap and the research problem. You want to highlight your motivation for the study, and then the potential significance of your research. They want to fund original research, and they want to fund high risk, high reward research. So make sure you have a detailed literature review and explain exactly what you propose to do and how you will do it, and include your hypotheses and implications of your research. So again, you want to start broad, address the problem that you're studying, and then your specific aims. So begin with your general information, and then state your specific aims and rationale, and draw the readers to the point of your study. What is the research gap you're trying to fill, and how your research will be an answer to the question that you were trying to solve. Make sure all your references and citations are complete. Make sure you have recent references. So you want to use a Mendeley or EndNote. Make sure preferably use recent from the last 5 years citations in your proposal. And poor references and citations may indicate a poor review of your literature. So refer to your grant guidelines for your format of the citations and references. Pilot studies, very, very important. Include results to any pilot study in your proposal. This helps to convince people that you are the right person to do the grant, and also shows that you have adequate institutional support, shows your project is feasible, you have the expertise, your hypotheses have merit, and this will evoke faith in your ability to deliver on the proposed research. So very important. So make sure you have some preliminary studies and include them in your proposal. So I would say this is like bait. It's a good bait for the funding organizations. They're like, oh, this is a good project to fund. They have the expertise and the know-how and the support to do the project. Expected results section, you will basically answer the question, what do you expect to find through the process of your research? Basically, this will be written in the future tense, so you can explain what you expect to have as results. And then you can present your expected key findings in the context of your research to your readers. You also want to maybe use some figures and when you communicate your expected findings. So you want to communicate all of this and make sure you highlight the novelty. The lack of novelty is one of the key reasons for a rejection. So you want to illustrate this in a concise, systematic manner, often using illustrations. So you may want to use text and tables and figures just to show your methodology, and then your expected research findings. It's also good to make a timeline. These are also nice graphical features of any proposal, and then flowcharts. These are great things to include in your expected results section. And here is a YouTube video. You can check that out on your own. And basically, when you have your research design, be prepared to communicate what statistical tests you plan to use, the ethical questions, ethical review, informed consent for human participants, your sampling criteria, recruitment plan, all these things, data management, confidentiality, maintaining that. You want to have your expected sample sizes and all the statistical tests ready, and then your timeline. So again, figures can be extremely helpful in communicating this. And it helps because I think the reviewers have a lot of proposals to review. So if you can communicate your expected methods and expected results, in a flow chart, this will really help you effectively communicate what you're proposing, what you're trying to do, and the questions you're trying to answer. So it's good to have nice, attractive, clear figures. So use flow charts. It's especially helpful when you're explaining procedures or recruitment strategies on a study. You could also use Gantt charts. Most of the research proposals I've applied that I've made and submitted to funding organizations, I've also used Gantt charts to show your timeline. Here's an example of a timeline. You can communicate what you expect to do in year 1 and year 2, the recruitment, the ethical submissions. So when do you plan to do the data analysis? So it's nice to have a Gantt chart, and these can be done. If you look at the previous web page or on this previous slide, there's a nice tutorial on how to produce one of these. It's very important to have limitations of your study. And so you discuss these. If you do not have, if you don't address these, the reviewers may be upset. So you want to discuss, every study has limitations. So it's good to list them. At least you're acknowledging them. Budget. As explained this before, this may take much more time than anticipated. So I remember one time I had 1 week left before submission. We had a good idea of the budget, but to fill out the budget sheets was so difficult. And I needed to sit down with the grants officer at my university, and they were able to figure out how to do it. A lot of them are spreadsheets. They can auto-calculate the different categories. You want to know like how much like the fringe benefits, for salaries of researchers. Every institute has different overhead costs, indirect costs, fringe benefits. So very complicated. So make sure you get an early start on your budget. Be prepared to justify the cost of every item on your grant. Also be flexible. If you can reduce your budget, say, oh, we can reduce the this part of the project. Some of the grants officers or the program officers, they might give you a higher rank on your proposal because you're showing that you're being flexible on your budget, or if you have other sources of funding to reduce the amount you request. So that's important. I'll show you a sample budget that you can give that information. So make an exhaustive budget. If funds exceed the grant allocation, explain that you'll be seeking additional funding from a different source. So here is an example budget. You have the salaries, you have the travel in here, you have the total amount of the grant, and then here you have, we have $15,000 from another funding source, and then you can request the total amount here. So this can actually help you a lot. And make your proposal more competitive. So personnel, you want to have the best team possible. Explain the responsibilities of every member of your team. Especially if you're hiring junior colleagues. You want to be able to train students, PhD students, postdocs, master's students, undergraduates. Make sure you list all these people in your grants. It's very important to show like any training, any additional certifications that will be sought from the team members before commencing the project. And to minimize expenses, maybe you'll have a person on your grant for only 1 year. So personnel can be phased out if their services are not relevant to certain phases of the project. So be prepared to rotate people in and out of the project, especially if it's like a 5-year project. Research environment, this is basically the facilities of your host institution. You can give a nice summary about that, what instruments are there, what field sites you have, and it's good to have a written agreement or letters of support from collaborators or from field sites, just to show you have permission. So your institute should have a good funding history as well. This is also very important. And then appendices, it's recommended that you include any extra information, for example, like letters of recommendation, support letters, or support letters from collaborators or from your field sites, and so forth. So just check to see what extra documentation can be included in your appendices and just follow the format. And then broader impacts. This is very important to communicate that not only you're doing great science, but you'll have a big impact on society. So there's different stakeholders who will benefit from your research. Make sure you clearly specify that. And then how you plan to share this information besides your publications. You can have newsletters, pamphlets, or even meetings or webinars or podcasts, or your research communication office. Basically all the outreach that you plan to do alongside your conference presentations and research articles and conference papers. So it's important, especially in the United States, to have these extra broader impacts. And the program officers love it. They really love it. A lot of my broader impacts just happen to be at random, like I would be on television, in China or something like that, and I would actually include the link, to the YouTube channel, or you want to show that you're making a broader impact. Other sections, there's research priority. This is in response to specific calls for applications. We can just show how your proposal fits the program solicitation, the impact of the beneficiaries of your research, and then intellectual property. A lot of times you can be asked, who will get the intellectual property? Will you patent your discoveries? How can you transfer the technology? Often the great discovery, you can actually take that discovery and make a very good practical application. And make a societal impact. So make sure you have this technology transfer is also in mind. And then final note on format. The format of every grant proposal can vary across countries and institutes. And while these 10 core parts of your proposal are most certainly included in every grant, there may be variations from proposal solicitations and different funding agencies. So make sure you follow what core parts you need. So follow the guidelines, and they have often very strict rules. So any deviation from these rules can result in rejection. Finally, I'm just going to quickly go over some tips, and then I'd rather spend more time on the Q&A. So I only have about 12 slides left. These are actually top 15 tips for effective grant writing. So an ounce of practice is generally worth more than a ton of theory. So practice, practice, practice. The more you write, the more you apply for grants, the better you get at it. So start early, allow enough time to write. Be comfortable with explaining the importance of your research, the broader impacts, follow the program solicitations, everything that I've explained up to this point. Make sure you emphasize your research quality, the scientific potential, this really, big, I would say, pie in the sky idea. these great ideas. They want to fund the next big idea. I think Google started out as a National Science Foundation grant with information technology, and it was a small grant, and then it turned into Google. They want to fund really innovative research. So you want to justify what tell the grant agency you can justify the value for the money that they're giving you. Review the literature in depth and be prepared to show the research gap and how your research fits into the body of known science. So you want to identify potential problems you may have and limitations and find alternative solutions. So have a plan A, B, and C. And then you want to ask yourself, will your findings still be relevant when the project is completed? So you want to clarify your research questions and then address the feasibility issues of your research. Keep enough time. When writing the application, again, 3 to 6 months for writing and another 6 months for the review stage. Create Gantt charts for writing various sections of your grant. So keep on schedule. Your writing time should be non-negotiable. The grants office said plan like 1/4 to 1/3 of all your time should be spent writing grants. So keep that time and don't let anyone interrupt you. You want to make a nice persuasive proposal, and it may take multiple attempts. So if you're rejected the first time, be prepared to submit a new grant the following year addressing the reviewer's comments. So stay on your deadlines. Be consistent and cohesive in your writing across all the sections of your grant. It should be one big cohesive story, and that communicates a very consistent message to the reviewers. So make sure your figures are clear and attractive. Use those Gantt charts, use flow charts. Make a timeline. Think from the perspective of your audience. Have a lay summary available. Your proposal will be reviewed by both experts and non-experts in your field. Get feedback. Again, I think this is the most important thing in the entire webinar. The proposal must impress the reader in 3 minutes or less, even if it took you 3 months to write. So get feedback before you submit the proposal, and you should capture the reader's attention, especially in your title and abstract. Avoid jargon. Make sure you have a grammatically correct proposal. You adhere to all page limits, formatting, etc., etc. Use a editing service, especially like Editage. They can help you along this task. Again, clear writing starts with clear thinking. So be mindful of your use of language and avoid acronyms and jargon. You want to communicate very clearly. Build an excellent team. Not only should you have junior researchers, but if you are an early career researcher, make sure you have one senior researcher on your team and collaborate with other researchers who have a history of successful grants and publications. So it's good to have a senior researcher also on your team. This is a good overall strategy for your grant. Don't be over ambitious or under ambitious. I've gotten in trouble with having an over ambitious proposal and I got rejected. So we made it less ambitious and then we got accepted the second or third year when we applied. So don't make too many promises. Make sure you can deliver on what you propose in your proposal. Include preliminary results. So the projects that are feasible and backed with scientific rigor and these pilot studies are most likely to be funded. And make sure you have all the resources available before you submit your proposal. And then be prepared to revise and resubmit. So many funding opportunities are within a research area. So applications can be recycled and resubmitted to maximize chances of success. Make sure you take into account the reviewer's comments when you do that. So incorporate comments from prior applications when revising grants, and this will increase your chances. Again, funding opportunities are low. The success funding rates are low. So treat the grant application as a learning process. So the biggest grants, I get rejected 2 or 3 years before I got the bigger grants. So follow instructions, incorporate the requested changes from previously rejected proposals, be realistic about your limitations, and then justify every item in your budget. And finally, this is just a summary. Critically review your request for proposals. Make sure you register early on all the websites, NIH, NSF, grants.gov, SAM, the Systems for Award Management. Discuss your feasibility and details of your research with your team. Plan enough time. Be consistent in your writing across all the different sections. Think from your audience's perspective. Avoid jargon. Use common language. Build an excellent team, and try not to be over and under ambitious in your proposal. And if you get it rejected, revise and resubmit. And again, if a cover letter is needed, it looks like the answer is yes. So communicate with the program officers and the granting agencies. You can go online, you can read about the program solicitation, find out who is in charge of the program, communicate with them. Write that letter of intent and the cover letter. Do a nice description of your project, 1-page description, be persuasive, and they can give you good feedback on whether you should apply, and also they can give you feedback on if there's any problems, and you can incorporate their advice in your proposal. And here are some useful resources for further references. Here's some tips from academicians on winning grants, some sample grants, different funding sources, and then here's a whole course on grant writing from Editage. Again, make sure your proposal is well structured, ensure that your scope of research is reasonable, and there are usually significant limits on the size and complexity of projects. So make sure they're feasible and you can complete your project within a limited time. And most importantly, make sure your passion for the subject matter shines through in the structure and arguments presented in your proposal. They want to hear from ambitious scientists with big ideas. They want to fund the big ideas. So make sure you communicate these broader impacts and these societal impacts. Those are most likely to get funded. There's lots of books that you can read on communicating science and writing a lot. These are excellent resources. These should all be in your library, and this book is How to Write a Lot is wonderful. Applies for both research papers and grants. And at this time, I would love to take questions. And thank you very much for your attention. I believe we have a good 10 minutes for Q&A. So thank you very much.
Thank you, Jacob Sensei, for special lectures. Let us move on to the Q&A session for about 10 minutes. If you have any questions, please click Q&A icon and type your question only in English. And then Jacob Sensei reads your question and answer it.
Okay, thank you very much.
Thank you. Jacob Sensei, please check your chat. There is a lot of questions from audience.
Thank you, everyone, for your questions. First question is about the percentage of foreign currency in Japanese research funds. Is it abnormally low from a global perspective? Well, from my experience, I'm not sure about Japan, but I've seen a lot of research grants, especially collaborative grants, that the foreign research organization, the amount of funding might only be like 1/3 of what the American funding agency will give. So it's hard to have equal participation. But there's other grants where actually they will award the grant overseas, so you don't have to go through JSPS as like a co-funding organization. So a lot of times the differences in the currencies doesn't matter because you'll get funding directly from the United States. But there's other funds, like, for example, National Science Foundation of US may cooperate with National Science Foundation of China or JSPS in Japan. And keep in mind, those projects, the funding from your home country might be a lot smaller than what the US gives. Thank you for that question. Are proposals from overseas also evaluated fairly. And what should applicants be particularly careful about? So with any grant application, I think the U.S., especially, there's a special office for overseas grants in the NSF, and NIH is also has partner institutes all over the world, and there is a tendency to treat every organization equally. When you're registering your organization on SAM, you are basically agreeing for equal opportunities, that you're following ethical considerations, and all the values, everything that's valued in the U.S. They want to make sure is, you're checking a lot of boxes when you're describing your research organization. So basically, you'll be on an even level as an American institute, just by registering as an entity on SAM. So these grants are actually designed for foreign cooperation. So generally, it also helps if you're applying for local grants as well. Sometimes they like to do a one-to-one funding match. So let's say you apply with the US, and then you have apply for maybe JSPS or your local health institute. And sometimes they will actually give you'll have a one-to-one match of your funding. You actually double your funding. So look at that as well. The cost sharing is sometimes a big part of these big grants. So it actually can be a benefit to be an overseas entity. Is novelty the most important part to get a grant? I would say yes. For the basic research, they're looking for novelty, novel methods, or have a big societal impact or a broader impact. And the grant applications, these are treated with the most highest level of confidentiality. You are often, in your preliminary results that you're giving, the pilot studies, these are not published studies. So you are actually sharing, like, you want to broaden the frontiers of science. And if you're showing that you have this novelty, that can increase your chances of getting recognized and getting funded. Next question is, how long does the final proposal usually end up being? Well, the full proposals, there's usually a limit of 15 pages, font size, 10 or 12 font, and some of the fellowships, they may be limited to like 5 pages, but you want to be able to include a lot of information, include everything that they request for in the call for proposals within that limit. They're also happy to receive shorter proposals because they review a lot of proposals. So the limit is 15 pages, but if you can do it in 10 pages, sometimes the program officers are really happy about that. So you want to make sure everything is understandable. That actually leads to the next question, that how often should we include content that's easier to understand? I think every method section should have a nice overall like snapshot summary of your methodology, have a flow chart. It's just much easier on people's eyes when they're reading a proposal. They have a nice flow chart. It might not communicate a lot of specific information, but it kind of gives a nice overview for the reviewers and also for the panel review. So it's not just empty space. It actually can make your proposal more attractive. So just consider that, but it'll be at the expense of your page limits. So do people really rely on text? Well, yes, but you also want to have an attractive proposal. So there's a balance there. I've reviewed some proposals, and I do appreciate having a well understandable progression of experiments. And I included that in almost every proposal, even though I feel like I'm taking away the text. The next question is, In the letter of intent, is it just like the cover letter? Actually, it's different. So the letter of intent is more of a communication to the program officers. And this clarifies like ethical considerations. You can talk about the pathogen you want to study, and then they'll get feedback on what recommendations from the program officer what you should include in your proposal. Cover letter, I think, will be read by reviewers. And sometimes a cover letter can be like a research statement, and this is a separate document that functions like a cover letter and basically can summarize all your research up to this date. So some grant proposals, not only do they want the biographical sketch, which is your 2-page CV, but also have a research statement that kind of functions like an overall cover letter. So be aware, yeah, those are different documents. But again, the letter of intent should not be submitted as your grant proposal. It's a separate communication to the program officers. All right, next question is about the communication plan. And does it need to focus on activities in the US? Well, not necessarily. You can include global activities. Like when I was in China, of course I would be on Chinese television. So, but some of the counterpart organizations in China, I'll just give China as an example. The Ministry of Science and Technology actually is in partnership with the Overseas National Science Foundation Beijing office and the United States Embassy in Beijing. I would actually be included overseas. National Science Foundation used to have an office in Tokyo, but it closed. So therefore, and just to wrap up, we have 1 or 2 more questions. Do I have any specific tips on fellowship applications?
I will check.
Okay, possible. And as we're wrapping up, any advice on postdoc fellowships, grants? To start with, I would start as a graduate student, the graduate fellowships and conference and travel grants. Also check out scientific societies. They often have early career researcher grants and travel grants. And these are great ones to start with. Graduate fellowships, I'll give an example. My first grant was only $5,000 for a summer research fellowship as a graduate student. Wasn't not a lot of money, but then after getting that grant, I was able to apply for a $200,000 postdoc grant. So the first small grants can open the doors for later grants, but I would start with the fellowships to begin with, and then you can apply for research grants later in your career. The last question, we have just about 1 minute left. Something about using ChatGPT. Yeah, it's no problem as long as you disclose the use of artificial intelligence and ChatGPT. It's so prevalent in our society that you can't avoid it. They may have ChatGPT detection tools, so make sure you can edit your manuscript to reduce the signs of using ChatGPT. It's almost impossible to distinguish. So just to wrap up, there's a final question from a PhD student applying for a postdoctoral fellowship.
When you finish, come to the fifth group and explain how the case groups and whom you should generate the return. Okay.
Okay.
I will be there for now. The next hour after that, I leave to the airport.
Okay.
Okay.
Thank you. And there's an interview. Sometimes there's an interview, and you should just be prepared to read the comments from the reviewers and address the comments during your interview. And that's it. Well, thank you very much for your questions. I'll turn this over back to the organizers. Thank you for your attention. Arigato.
Thank you, Jacob Sensei, for answering many questions. As it is about time to end, we are in the middle of receiving many questions from you guys, but we will close Q&A sessions. Questions that could not be answered today will be answered a few days later and made available to you guys in our email newsletter or social media channels. And the recording of today's webinar will be posted on our YouTube channel. So please subscribe. Also, please don't forget to follow our social media to receive more information as we plan to other events in the future. Okay. Please wait. And now let us ask you to fill out our survey. We would like you to answer the survey questions. We will use your feedbacks on today's webinar to help us improve our webinar quality. Okay. Please scan QR code in the screen and answer a few questions. If you have any trouble scanning, we sent you the survey link in this webinar chat. Thank you, Jacob Sensei, and thank you all for joining us. We will now conclude the webinar. Thank you so much.